So today we are going to discuss about the HVAC load calculations of swimming pool. Um, when we talk about swimming pools or natatoriums, so there are several types of HVAC loads that are associated with a swimming pool, indoor swimming pool design. So let's talk about all the loads that contribute in the heat uh, in a swimming pool. So first of all, heat comes from the outdoor air. Outdoor air is essential to maintain proper air changes per hour inside the swimming pool, and it's essential to avoid bacterial growth and to eliminate all the chloramine smell in the indoor space area. And then we have the internal loads like loads for people and electric equipment load or lightning load. And then we have our convection, and radiation loads from wall, roof, and windows. And then we have a main load that is evaporation load in swimming pool design. Basically, the surface of swimming pool is very critical because there is evaporation all the times, and due to that evaporation, humidity level increases inside the swimming pool, and it is very essential to maintain proper relative humidity inside the swimming pool. ASHRAE recommends to maintain a relative humidity of 50 to 60%. Um, Today we are going to have a load calculation of this swimming pool, indoor swimming pool, and we will see that how we can add all the loads in app so we can have our desired load calculation results. Let me open, first of all, let me open map 5.1. So basically, when you create a space, so what you have to do basically is, sorry, I am on system side. Um, this is space. So I have created a swimming pool space. Okay. So first of all, you have to find the area of swimming pool, which you can find from AutoCAD file. Like I have a swimming pool area, and for in case of evaporation, you just have to select the pool area in which there is water, not the side area or the spectacular area. Just the swimming pool area is required. So first of all, put area of the swimming pool in half five. Okay, and then the ASHRAE 62.1 standard for swimming pool, like for if you are calculating it for the pool side, so it is required to maintain 2.44 liter per second per meter square. Uh, it's an area criteria, and if you are designing for a spectacular area, so you have also got standard of per person, basically per person, liter per second or CFM, and also the area criteria. So after selecting this ASHRAE standard 62.1, which is basically the ventilation standard, you goes to internal loads, and where you put the electric load here, the electric equipment load. I took it randomly, like 500 watts. There may be no electric load, or maybe due to some screens or displays. And then you have a lightning load, okay, and then you have to select the occupancy. And here our basically today's topic that we have to add the miscellaneous load, which is basically the evaporation load. Uh, in swimming pool. So the evaporation contributes in latent load, And today we will see that how we can calculate this evaporation load of swimming pool. So let's come to the topic. If you go to ASHRAE applications, there is a chapter of swimming pool. Let me move towards to- yeah. So there is standard of ASHRAE guidelines there are, and which says that the evaporation rate is equal to 4 metric 10 to the power minus 5 um, area, and then you have the vapor pressure at the surface of water minus the partial vapor pressure of vapors in the air. And then you have a factor, activity factor. Like actually, I've divided swimming pools according to their activities, and like there are types of pools: recreational, computational, diving, and it suggests accordingly the air temperatures and water temperatures and the relative humidity respectively. And also based on the type of pool, there are some activities factor like for hotel swimming pool, this is zero point 0.8, for public school, it is 1, for residential pool, it is zero point 0.5. So these values we will incorporate in the main equation uh, uh, calculating evaporation load. So let's move forward and uh, calculate evaporation rate of this swimming pool. So first of all, I calculated the pool area, which in my case is 520 meters square. Okay, I calculated from the architecture plan. Okay, and then you have to consider our activity level. And for my case, I took activity level 1, which is for public schools or recreational activities. So in my case, I took activity factor 1. And then you have to decide the water temperature of swimming pool and the air temperature of swimming pool. And this is the most critical part that an HVAC design engineer have to implement, like what will be the temperatures, because it has a direct impact on the evaporation rate and latent load, or you can say the humidity level inside a swimming pool. So what happens if you, first of all, I will tell you that the recommended design criteria is that you have to keep air temperature 1 degree above the water temperature. And basically, this helps to maintain a higher vapor pressure at the air side so that when you have a small pressure difference between water side and air side, so there will be less evaporation. So for that purpose, we take air temperature at a high side than water as compared to water to have more vapor pressure at the surface of at the air side, so that there should be a restriction in evaporation rate, so that the molecules cannot easily escape the surface of the water. So for that purpose, these are the temperature. I took 27 centigrade or 80 Fahrenheit as water temperature, and 28 degree or 82 Fahrenheit as air temperature. So what is the next step is that you have to find saturated vapor pressure against these temperatures, and you have to go to a steam table. Like for first of all, we will find water surface vapor pressure. That for purpose I have selected 27 degree, and now I will go to my steam table. Uh, So for I will look at 80 Fahrenheit, okay, and this is 80 Fahrenheit, and against that I got a vapor pressure of 0.506 psi. Okay, so 0.50683 psi, and then I converted it in kilopascal by multiplying it um, with 6.9. So here I have done this on Excel sheet. 0.506 multiplied by 6.9. So um, now I have got the value PW. So again, if you see this equation, WP is equal to 4 multiplied 10 power minus 5 area, and the pressure difference between water side and air side, and then factor of activity level. So we have got the value of area, we have find out activity level, and we have found PW. Now, what is remaining is PA, which is the partial vapor pressure of water molecules inside the air. So, what you have to do, you have to first check your temperatures, which I have maintained 28 degrees centigrade or 82 Fahrenheit, and then you have to decide that how much relative humidity you want to maintain at that space. For my case, I am maintaining a relative humidity of 50%. This is where I have mentioned. And what you have to do now, and that you have to find the dew point temperature, which you can use psychometric charts or psychometric calculator. I have used psychometric calculator. Against these two values, I have found a temperature of 16.64 degrees centigrade, which is almost 62 Fahrenheit. So after finding this 62 Fahrenheit temperature, again, I have to go to steam table. Uh, and I have to find vapor pressure against 62 degrees centigrade, 62 degrees Fahrenheit, which is 0.27494. Um, so again, converting it into kilopascals. So I have got vapor evaporation rate that is 0.03328, and how I got that is from the this equation, this main equation, and I will click from this formula that 10 K 4 multiplied 10 raised to power minus 5, and activity level 1, and then area 520, and there is a pressure difference, vapor pressure difference, that is 3.49 minus 1.89. And after that, I got evaporation rate in kg per second. Okay, so after getting this evaporation rate, you have to find out these vapors, latent heat, or you can say the enthalpy they have, so that you can calculate the BTUs per hour, or you can say kilowatts that contribute in the heat flow. For that purpose, you have to go to the temperature, that is your water temperature, okay, which I have maintained 27 degrees centigrade or 80 Fahrenheit. So you have to go again to steam table, and you have to go to 82 Fahrenheit. And here you see the uh, enthalpy that is inside the vapor dome, not the liquid side, not the vapor side, but inside the vapor dome where the phase changes, and you will find the enthalpy value, that is 1047 against 82 Fahrenheit temperature. So I got that evaporation value, which is this also enthalpy value, that is 1047, and to convert the units, I multiplied it with 2.326 to get a kilojoules per kg. Kilojoules per kg, I got the value. So yeah, forget to wrote here, but I have written it on the Excel sheet. So this is 2435, and when I multiplied my kg per kilojoules per kg in enthalpy with the evaporation rate, that is 0.033281, I got kilowatt of 81 kilowatt latent load. So this is our final kilowatts. Okay. So in this way, I calculated the latent load which I have to put in at this side. Latent is 80, 81,000 watts. Okay. So then just have all the windows and you similarly that you did for all the other spaces and then okay, great, okay. And ASHRAE recommends to have an air change per hour of 4, 6, or 8, depending on the how much is the activity level here. So what you can do for that, you have to select the design uh, system, okay, and maintain a chilled air handling unit or DX air handling unit. The selection is up to you. Um, and for maintaining ACH, you have to go to zone components and then supply thermal supply terminals. And here you can select this. Initially, it is in liter per second, but I already have written ACH required, that is for ACH. And then we do all the stuff that you normally do for all the spaces like maintaining thermostats according to your needs or according to your according to your selection. As I have maintained a 28 degrees centigrade at here, so I can write 28, 28 for summer conditions. For winter, I can go with 27. It's not a good thing. So, yeah, so in this way, you can have the load calculations of swimming pool. Hope you find the best way of finding the loads of internal swimming pool. Uh, its design is always a challenge and a critical thing. You have to eliminate the smell of chloramines that are formed by chlorine and some bacteria generated by human body or swimmer's body. So these chloramines gases evaporate, or you can say that mix diffuses into the air and creates a smell. So you all have to exhaust the air and maintain proper air changes for all. You have to maintain a relative humidity. You have to provide air at the breathing zone so that swimmers can have uh, no issue with the indoor air quality. And also you have to have a proper air distribution so that there should be no bacterial or fungi due to condensation, or you can say due to stagnation points where air don't reaches and that condensation, or you can say that dehumidification was not taken into consideration. So there are a lot of things when you have to consider it. But also the chemical composition and the water treatment there plays a essential role. Always plays a essential role in maintaining a good air quality, and without their input, an HVAC design engineer cannot maintain a proper healthy environment um, just by his own belong. So it's a contribution of each and every department and together to make the Natatoriums better place to enjoy. So hope you got all your queries. If you have any question, you can ask me in the comment section, or you can follow me on LinkedIn. I have mentioned my account in the description. So go and follow me and keep supporting me. Thanks.